In this lecture, we're going to go over using parameters in ROS2. Parameters are essentially dynamic variables which are associated with nodes. These dynamic variables have information stored in it, which can be set, retrieved, or changed freely. Parameters can have a variety of uses, like keeping track of the state of a system, or have data related to, say, physical attributes of the robot. Let's go ahead and open up a terminal and run the RPM pub node we created in the Publishers and Subscribers project. Once it is running, we will go ahead and open a new terminal tab and launch the speed publisher we created in the same project. Then we will open one more terminal tab and run ROS2 param list. Here we can see a list of parameters sorted by node. In this case, both of our nodes have a series of QoS related parameters, as well as a parameter called useSymTime. So this is just default parameters added to nodes when you start them up. We can see the value of parameters by using the ROS2 param get command. This command takes in the name of the package and the parameter we are interested in. In this case, I will get the parameter from the RPM pub node and specify the useSymTime parameter. We can see this parameter is set to false by default, which means it uses the time on our computer. You could set it to true if you wanted it to use the time being generated by a simulation you may have running. If you want to see more information about a parameter, you can use the ROS2 param describe command with the same arguments. Here we can see the type and any constraints the parameter may have. Alright, for now I will go ahead and stop all these nodes from running. Alright, so how can parameters be useful for us in our ROS code? Well, in my RPM publisher node that I did in the project walkthrough, I hard-coded the value of our RPM to simulate a wheel encoder sensor going at a constant rate. Instead, let's use a parameter so that if someone wants to change the RPM value, they don't have to edit my source code. As always, you can check out the ROS C++ API docs on parameters, but with my VS Code open on my RPM publisher file, I can use the declare parameter function right after I initialize my node to create a parameter called RPM val, which I will cast as a double type. Then optionally, I can initialize the value of this parameter. So for our case, let's initialize it as this RPM value we have above. Now I plan on changing the RPM value with the parameters, so I will change the name of this variable to describe it as the default value. Then I will create a new attribute in our RPM pub node class called RPM val param and set it equal to this default value. I could have just initialized the default value directly here to get rid of the constant variable declaration at the top, but I prefer to keep potentially modifiable variables values at the top of the file where it is easy to see, so I will leave it as is. But this new variable is also going to serve as a variable to load in values from the parameter should it change. Let's see how this works. Now we want to publish whatever the value of the parameter is, which I can do with the getParameter method of our node. This takes in the name of the node and the variable we want to load the data into. Then we can modify our message data we send out to be the value of this variable we just loaded the parameter value into. And then the one thing I actually just realized I forgot was to initialize the declared parameter, which I will do with our RPM default variable constant. Great, so that's it. We declared a parameter called RPM val. We created a variable to load in the default RPM value, and then use this variable to load in the current value of the parameter using the getParameter method. So let's save this file and rebuild our project to better understand how this works in action. Alright, so that's gone ahead and rebuilt, and I'll head back to our terminal. And I'll rerun our RPM pub node. I'll go ahead and clear the screen first. And then I will clear this screen. And we'll run our ROS2 param list command again. And we see our new RPM val parameter, which we can get the value of like so. And here we see the default value of 100. And we can verify that this value is getting published. And we see that same value. Now, if I wanted to change this value getting published, I just need to change the value of the parameter, which I can do in a different terminal tab with the ROS2 param set command. So actually go ahead and rerun this echo command so that we keep seeing the value printed to the screen. And in the second terminal, I'll go ahead and clear it and set the parameter to a different value. and I'll set it to something, say 50, which is half the speed. And now we see the new data coming in shows 50 instead of 100. Cool. So with that, we have implemented parameters into our node. Now there's one more way to go about organizing your parameter functionality in your code. So going back to our RPM publisher code. So here we declared a float variable, but we could have instead declared a parameter object when we used getParameter. So I will comment out this RPM val param variable. When I call getParameter, if I don't provide a second argument of an existing variable, then it will instead return a parameter object. So I can declare the new parameter variable locally within this function. Then to convert it from a parameter object to a C++ data type, I can use one of its as methods. So here we have a few different types, such as Boolean, integer, double, string, and array versions of these types. So I will use the asDouble method so that it is a suitable type for our float64 message. Then, just to show you this works properly, I can go ahead and save the file and recompile our workspace. Alright, we head back to terminal. Go ahead and clear the screen and rerun our RPM publisher node. And we see it works just as it did before. So hopefully you can see that either format works, either by declaring a parameter object and converting it, or by passing in your pre-declared variable of a particular type, and it will do the conversion for you. Congratulations! You successfully implemented parameters in your very own ROS2 code. It is worth noting that if you have multiple nodes that you want to share parameter values with, you can use ROS services to request the parameter variables between nodes. Now, we'll learn about services later on in the course, so don't worry about it for now. In the next lecture, we'll be learning about launch files, where we can automate the launching of nodes as well as setting of parameter values. All right, in this lecture, we talked about ROS parameters. We learned about several terminal commands which can help us manage our parameters of our nodes, such as ros2param_list, which shows a list of all of our nodes and the parameters they have, as well as ros2param_get to get the value of a parameter from a particular node, as well as ros2param_set, which allows us to set the value of a parameter of a particular node. Then we went ahead and implemented parameters in our C++ nodes, which we did with the nodes declare parameter function, which we then specify a type, like in this case float, and then followed by the name of the parameter and the value, which matches the data type. You can then get the value of the parameter and load it into a particular C++ variable by calling the getParameter function of our node object.